All right, today we're tackling something pretty wild. It's a story about AI, but not the one you usually hear. We're going to pull back the curtain and uncover this totally surprising, almost accidental secret behind how these machines actually learn to talk like us. You've probably played around with these modern AIs, right? I mean, they write poems, they answer these super complicated questions, they can even just chat. It's amazing. But the real question, the one that really gets you thinking is, how? How does a pile of code create something that feels so human, so creative? Okay, so get this. The answer to this very modern mystery isn't sitting in some high-tech futuristic lab. Not even close. It turns out it's actually hidden away in a 50-year-old linguistic theory. Yeah, seriously. To understand the future, we have to go back to the past. So first up, AI's spontaneous genius. And that title really hits the nail on the head. What makes these models so mind-blowing is that they develop these complex skills pretty much on their own. It's a thing scientists call emergence. And it's kind of like magic. I mean, just think about it for a second. Nobody is sitting there teaching these AIs grammar rules, right? Like subject, verb, object. Nope. They just learn. They get fed massive, and I mean massive, amounts of text, the entire internet, basically. And somewhere in all that data, something incredible happens. They start to build their own internal rulebook for language, all by themselves. Okay, section 2, a forgotten blueprint. This is where the story takes a fascinating turn, because our first big clue comes from a really unexpected place. We're talking about a linguistics text from the Soviet era, all the way back in 1972. It laid out a plan for language that AI would, completely by accident, rediscover 50 years later. So this old theory basically said, hey, language isn't just a flat string of words. It's way more structured than that. It's a complex, multi-level system. Think of it like building blocks, a hierarchy, where each layer builds on the one right below it. And they called it the classic language ladder. It's a really great way to visualize it. So at the very bottom rung, you've got phonemes. Those are just the basic sounds of a language. Then you climb up a step, and those sounds combine to make morphemes, which are the smallest bits that actually have meaning, like prefixes or suffixes. Then, another step up, those morphemes build words. And at the very top, words get structured into sentences. See? It's a ladder, from simple to complex. All right, section 3, 3 systems, 1 pattern. Now, this is where things get really, really interesting. Because this exact same pattern, this language ladder, it doesn't just show up in this old theory. It pops up in 2 completely different places, modern AI and our own brains. It's like biology and technology stumbled upon the very same solution. Let's start with the AI. There's a famous model you might have heard of called BERT. And when researchers took a peek under the hood, they found something amazing. BERT had, on its own, figured out this whole linguistic pipeline. It organized itself to process language in that exact same hierarchical way. So, BERT is built in layers, right? And it turns out each set of layers has a different job. The first few layers, the early ones, they're just dealing with the basics, sounds, pieces of words. Then you move into the middle layers, and they're focused on grammar, how a sentence is put together. And finally, the late layers. They do the heavy lifting, figuring out context and the actual meaning. It's literally the language ladder, but built by an AI. But hold on, because the story gets even wilder. That same pattern isn't just in the machine. It's in us. Neuroscientists have found that our brains use a surprisingly similar system to handle language. They call it the dual stream model. Basically, our brain has 2 main language highways. There's the how path, or the dorsal path, which connects sounds to the physical act of speaking. It's the mechanics. And then there's the what path, the ventral path, which connects those sounds to what they actually mean. 1 part for doing, 1 part for understanding. Okay, so look at this. It all lines up perfectly. The simple stuff, the sounds and the grammar, that's BERT's early layers and the brain's how path. The really complex stuff, the meaning, the semantics, that's BERT's late layers and the brain's what path. You've got classical linguistics, a modern AI model, and the human brain, and they all independently came up with the exact same blueprint for language. It's just incredible. Section 4, and here's the twist, the limits of mimicry. Because as amazing as this parallel is, it also shines a giant spotlight on a huge fundamental difference. And that difference is the key to understanding AI's biggest weakness. So even though the structure looks the same on the outside, what's happening on the inside is totally different. See, we humans learn language using abstract, symbolic rules. We build this sort of mental dictionary. But AIs? They're all about statistics. They don't learn rules. They just get incredibly good at spotting patterns from the billions of examples they're fed. They're master mimics, not rule makers. And that's where the problem comes in. This difference leads to what researchers call a surprising fragility. Because the AI's knowledge isn't based on real, abstract understanding, it's brittle. You can make a tiny change to a sentence, something a person wouldn't even blink at, and it can completely throw the AI for a loop. Its whole understanding just shatters. So here's the big takeaway. AI is an absolutely incredible mimic. It has mirrored the structure of our language perfectly, but it isn't thinking like us. It's a ghost in the machine, reflecting the architecture of language, but without actually grasping the deep, symbolic understanding that gives it real meaning for us. And this whole thing leaves us with a really big, really provocative question, doesn't it? If a machine can perfectly copy the structure of our language without any real understanding behind it, what does that say about intelligence itself? How much of what we think of as intelligence is just really, really sophisticated pattern matching? And what part, if any, is something more? Something to think about.